Alrighty, so today's gonna be pretty short because I already recorded on Tuesday. I just wanted to do this momentum conservation because it's from my exam too, and it wasn't going to be on this exam, but before I forget, I'm just gonna do it. So we have two rocks, and they're gonna collide, and they stick together. So I'm pretty sure that means it's completely inelastic. But either way, momentum is conserved. So you're gonna be able to use your P equals mv equation. So that's your momentum equation. Then let's go ahead and label some of these. So it says rock A is 10 kilograms, so that means mass A. I'll leave space for the A. Kilograms. And similarly, velocity of the rock is 15 meters per second. BB, or sorry, mass of the rock B, so MB is 14. Velocity of that same rock is unknown. That's what we're solving for, I believe. Let me go ahead and draw in. Okay. These are supposed to be subscripts. And then it says that after they collide, this is a 40-degree angle. The dot is degree. So note that for the rock A, this is completely on the x-axis. And for rock B, that's completely on the y-axis. And at the end, you have a vector vector components of x and y. That one's going that way, and this one's going up. Yeah. So then in our x direction, we have, I'm going to type it since it should be faster that way. Mass of, yeah, beautiful. P of A all these spaces plus P of B equals P of A and B. And then that's going to become M A V of A B P of B M of A plus B B final. And I know I'll go write things in right now. You sum the masses of A and B because they stick together. So that's how you know that you're summing them or adding them up. Because that means the new point that's moving is like both of them stuck together. I'm just gonna do this as V final. So VF. So then I would just isolate for V of F. So then you're gonna just divide by MA plus B. M of A plus B of A. Sorry. Plus M of B. So what that does is that cancels this out and leaves you with a VF equation. And then you're gonna do the same thing for Y. See if I can type it. So M of A. I'm not gonna be able to write that in. Am I? You guys understand if I just do M? No, I should probably just write it. And I actually realized I forgot to include the x's over here. So the masses stay the same, but velocity is for x on all of these. So then this v of f of x, because the x is over here, so that's cosine, right? So katoa, this is on the adjacent side from the angle. So the oh my gosh. Sine theta. So then you're also going to divide by cosine theta here. Because you're just isolating for v of f. Right, so then those two can't cancel out. Like, for there. Okay. So now let me M of A times V of AY. This stuff you just really have to watch what you're working with. Okay. Save this part. I'll leave space. Okay. Because again, that's over here, so it's opposite, which is so opposite of right hypotenuse, sun. Cool. So then we're gonna go ahead and divide both sides. Probably should have done the division in blue up here, but oh well. You guys get that I'm dividing, canceling things out. I'm gonna try and oh no, not the B. Or the B. We want to be on the other side. Sorry, I'm not sure if you guys can tell. I'm a little tired today. We're just canceling out for isolating. Those two cancel out. Well, the B stays there. And then that's yours equal to VF equation. So then we need to note some things that we noted earlier. We see that this one is just X, only X. So that means that V of A is only in the X direction. Same thing for the V of B, which is only in the Y. So that means it's only in the Y direction. That means that V of B of X is equal to 0. And V of A of Y is equal to 0. Cool. And from now on, because it's a pain to write, I'm just going to write this as MAB. Cool. So from there, we can go V final is equal to V final. So then we're going to set both of them to equal to each other. I'm probably just gonna write it out. And with A. And X over MEV times cosine theta equal to V times VBY, which is just VB, over the, I believe this one should be sine, yeah, sine theta. It's a theta. I don't have much room, but if you multiply those to each other side, okay, better yet. I don't have much room, so let's just isolate this. And the way you're going to do that is going to multiply by this MB sine, the inverse of that. So I'll probably write it out that way. See if I can actually type it. So we have M AB sine theta times M A B A space for stuff. That's gonna be over B times no, that should equal to VBY. Jeez, it's cutting into there. That's your line here. I feel like we're encroaching on this territory a little bit. There we go. Time to erase the fin. Okay, so this sign here came over here, right? This AB came right here. Same thing with this MB came here. We're dividing these. This MAB cosine was already there. And then you already had your MABA. That should go to MBBY. Right. So we kind of just cancel this stuff out and multiply it over. So it would be like, this was what was already here. And then you multiply this, the inverse of this to cancel those out. So then because we're multiplying it all out, we see that this MAB and this MAB cancel out. And then remember that, do a different color just for a little bit. this sine over cosine here is the same as tangent. So from there, we get M space for the A, V space for the A over MB times tangent theta equals to VB of Y. So then if you plug that in, that gives you, what is this mass? 10 kilograms. Times 15 meters over seconds divided by near 40 degrees. And don't worry, I'll draw stuff in. Yeah, also draw one. Oh, wrong color. Draw a line here. Because these two are separate things. Okay, so M A V A of X, which is really just VA divided by MB tan theta times tan theta is equal to VB of Y. And then you take all of that, divide this. And you're multiplying all of this by tangent theta. So then that gives you, I don't have room here, so I'm just gonna put it over here. That should give you VB is equal to 8.99 meters per second, which is about 9 meters per second. Because this VBY is just the same as VB. And that's your answer. Cool. Take a screenshot of this. Cool. So I guess that actually did end up going a little long, but oh well. So anyway, we got like 9 meters per second. And if you look at the exam key for my year, this is from my year, not from your guys' year. She does it slightly differently where she solves for V of X with the, yeah, she solves for V of X and then she plugs that in for V of Y. To solve for VB. Either way, you're gonna get about 9 meters per second. I hope you guys have a good day and take care. Let me see record button. There it is. Take care. Bye.